Okay, limit 6, factor, reduce, and piecewise. 1 through 13 are factor and reduce, holes that are removable. These are the limits that we covered in video 5 in detail. Today we will cover piecewise, that are continuous or holes. When you see x equals not equal to -1, what does it mean to you? Well, it should mean that x is less than 0 or x is less than 1. So when you see a problem that looks like this, what does it really mean? It really means that x plus 6 is both less than 1 and greater than 1. This is just a nicer notation. It takes less space, but it means the same thing. So, yes, when we see x not equal to 1, it means that we're looking and examining 1 from the left and 1 from the right. This is extremely important to know for 14 to 19. For the first two examples, I will double write these. You should get sufficiently tired of this and succumb to the fact that when x is equal to a particular constant, it means that we're approaching not only from the left but from the right. We're just not at the constant. So, for example, f of x is equal to 1 minus x over 3 when I am not 2, and -4 when I am 2, and I want to find the limit. Well, I could rewrite it because the 1 minus x over 3 is on the left and on the right, and I could do it this way and see 2 from the left and 2 from the right, or I could just accept the fact that this means 2 left and 2 right. If I accept the fact, since I know that the limit exists only if the limit from the left equals the limit from the right, and that's the limit, then this problem is simply direct substitution. The limit as x approaches f of x is going to be the limit as x approaches 2 of 1 minus x over 3. 1 minus 2/3 is 1/3. Note, I went ahead and found the function value. F of 2 is -4, to see that these two are not the same, and therefore there's a hole at 2 1/3, and it's not continuous. Now, if I actually take this and force myself to rewrite it, then I have to do the ABC game. I have to do the limit from the left as I approach, the limit as I approach 2 from the left, and then I have to do this same exact work for the limit as I approach 2 from the right. Yay, what a shock, they're equal, and my limit's 1/3, and then I still have to find the function value like I did over here to show that it's a whole and not continuous. Here's a little sketch of what the picture might look like. We have an oblique line with negative slope and the ordered pairs below. You can see if I just erase that and fill that in other words, mark it out, fill it in, that I would be continuous. Hence, that's why a hole is called removable. Let's do another one the same exciting way. So if I just get with the fact and know that that means x is less than -1 and x is greater than 1, so it's both left and right, what can I do? Direct substitution, I get -2, but the function value is 0. These are not equal. Therefore, -1, -2 is a hole and it's not continuous. And again, this is another oblique line with negative slope, only the ordered pair would be above. Again, why is it removable? Because if I could erase that and just move it down there, it would be continuous. But oh no, you say you are too frustrated. You cannot learn that x is not equal to -1. Means both the left and right. You feel the need to rewrite it as x is less than -1 and x is greater than -1. So be it. left, right, at, function value. Then you have to play the ABC game. Limit from the left at -1, -2. And what a shock, since it's going to be the same direct substitution. The limit from the right of -1 is 2. They're equal. Again, such a shock. And so the limit's -2. The function value is still 0. And hence we still have the whole. Everything's the same. Now I'm not going to do this again. You need to just get with the program and learn that x not equal to a means x is less than a or x is greater than a. It means I'm approaching from the left, I'm approaching from the right. That not equal to is both symbols at the same time. So no more rewriting. So here we are. F of x is equal to x squared minus 2x minus 24. When x is not 6, notice how I'm just going to assume it's both left and right because that's what that means. And then it's 5 at 6, and that's my ordered pair, my function value. There was no sun until I started recording. I'm sorry. So now the limit as I approach 6 of f of x is just a one time, because remember this means near, not at, and this means near, this means at. So I just take the expression, I direct substitute, I get 0. But we have a function value that's not the same, hence it's a whole and not continuous. This is a picture of a parabola. And again, notice the function value is above the whole. And again, I could remove that. If I could just erase that and rename it that, I would be continuous. So this is limit 6.